Space travel demands extreme precision, tolerances in microns, calculations to the decimal. Docking has always been one of the most nerve-wracking challenges. Two massive machines racing through space must connect with a feather-light touch. Imagine threading a needle while riding a roller coaster. NASA's solution? Docking systems that were masterpieces of complexity. Sensors, computers, motors, all choreographed for a gentle, impact-free connection. Spacecraft would approach at a crawl, guided by lasers and cameras, aligning perfectly before mechanical latches engaged. This required mountains of hardware, endless redundancy and obsessive testing. The result, reliable, but heavy, slow, and expensive. Every component had backups, every line of code was scrutinized. This wasn't just engineering, it was a culture of extreme caution, born from the need to protect billion-pound assets and astronaut lives. The philosophy became gospel: approach slowly, align perfectly, connect with zero impact. For decades, no one questioned it. Each new system was just a slightly improved version of the last. The fundamental approach never changed. It was a beautiful, intricate, and incredibly complicated ballet in the stars. Then SpaceX arrived, and they don't do gospel. Their philosophy? First principles thinking. Break problems down to their fundamentals, ignore assumptions, and start from scratch. When SpaceX tackled docking, they didn't copy NASA's blueprints, they started with physics. The real challenge isn't avoiding all impact, it's managing energy. Traditional systems tried to make energy transfer zero. SpaceX asked, what if we just absorbed the energy safely? This was a radical shift. Focus on docking without damage, not docking without impact. By reframing the goal, they unlocked simpler, more creative solutions. SpaceX's mindset: be a physicist first, engineer second. Don't accept complexity or cost at face value. Question everything. Strip away decades of assumptions and bureaucracy. It's uncomfortable for some, but it's how breakthroughs happen. That's how you go from a complex ballet to a robust, simple solution. With a new goal: absorb energy, don't avoid it. SpaceX found inspiration in an unlikely place: a mountain bike. A bike's suspension soaks up impacts with springs and dampers, keeping things stable. It's simple, elegant, and purely mechanical. The light bulb moment: build a docking system that works like bike suspension. Enter the McDocker, a device using springs and dampers instead of motors and sensors. Dragon approaches, makes contact, and the McDocker compresses, absorbing the impact and rebounding to seal the connection. No complex computers, no heavy motors, just physics doing the work. The system is passive, lighter, cheaper, and more reliable. Fewer parts mean fewer failures. The McDocker could handle misalignment and off-center impacts, something old systems dreaded. It was robust, forgiving, and tough, designed to take a punch. This wasn't just swapping motors for springs, it was a philosophical shift. Inspired by a mountain bike, Gercher, Yerster, Daber, Ber, Aulau, Baudoi. The McDocker upended decades of spaceflight dogma. Sometimes the most elegant solution is the simplest one. The McDocker proved that, and it changed everything. When SpaceX pitched the McDocker to NASA, skepticism was sky high. NASA's engineers had spent careers perfecting gentle, zero-impact docking. The idea of bumping the ISS sounded reckless. Concerns were real. Could the impact damage the station? Would the springs work as promised? SpaceX had to prove it, so they built, tested, and pushed the McDocker to its limits. They simulated every scenario, gathering data to show the system was safe and robust. The ultimate test came in orbit. May 25, 2012, Dragon docked with the ISS. The McDocker performed flawlessly. A small controlled impact, a secure connection. Since then, Dragon capsules have docked dozens of times, for cargo and crew. What was once radical is now routine. Creative, first principles thinking had set a new standard. The McDocker story reveals SpaceX's unique engineering culture. Here, small teams own problems and are empowered to question everything. Instead of endless committees, SpaceX moves fast. Build, test, break, learn, repeat. The mantra: the best part is no part. The best process is no process. Rapid iteration: build, fly, fail, fix, drives innovation at breakneck speed. Tradition isn't sacred. Logic and physics rule. SpaceX engineers ask, what's the smartest way to do this now? They're not burdened by legacy. They're focused on results. Safety matters, but it's achieved through robust design and relentless real-world testing, not analysis paralysis. Failures are learning opportunities, not disasters. Practical results beat theoretical perfection. This culture built the McDocker and is revolutionizing access to space. It's noisy, messy, and it works. That's the SpaceX way. The McDocker isn't SpaceX's only example of radical simplicity. Consider the Falcon 9's payload fairing, the 5 million-pound nose cone, once discarded after every launch. For SpaceX, throwing it away was unacceptable. The challenge: how to recover it. Initial ideas, parachutes and helicopters, were complex and failed, so they broke the problem down. The fairing can be steered and needs to be caught. The solution: a giant net on a fast-moving boat. They equipped fairings with thrusters and steerable parachutes, turning them into guided paragliders. Ships with massive nets, Ms. Tree and Ms. Chief, waited below, ready to catch. It took many tries, but on June 25, 2019, they caught their first fairing. A multi-million-pound problem, solved with a parachute and a net. Like the McDocker, it was about ignoring tradition and focusing on fundamentals. Simpler, more robust, and game-changing. SpaceX's approach: challenge assumptions, find the elegant answer. That's innovation. What's the big lesson here? Simplicity. In engineering, it's easy to add complexity. Sensors, backups, layers of redundancy. But true innovation comes from subtracting, not adding. SpaceX's first principles approach is a masterclass in simplification. Challenge every requirement. Is it truly necessary, or just inherited baggage? By changing zero-impact dock to dock safely, they unlock the McDocker. Relentlessly optimize. Can you remove a part, combine functions, or simplify further? Trust engineers, prototype rapidly, and test wild ideas. Boil systems down to essentials. Make them robust and reliable. Progress isn't always about more tech. It's about understanding fundamentals and questioning the status quo. Whether building rockets or solving daily problems, break things down. Focus on what matters, and build from the ground up. That's how you change the world.